To show you is how to do this concrete group testing data, okay, and analysis based on your graph's data. Now what I'm going to assume, or what you should assume, is that you've already answered questions 1 through 6, because we did that before. So we're going to start with number 7, and we are going to look at our graph. I have an example graph over here. You have to do your own graph, all right? So I'm doing this as an example. So if I look at number 7, it asks, what is the equation of the best fit line of your graph? So I look on over and I see, oh, there it is. 535x plus a negative 1534. So what I write down is y equals 535x minus 1534. All right, that's my line of best fit. If you note, that's in the y equals mx plus b format. Okay, some special name for that in math, but I don't know that. Let's go to number 8 then. So now we're using this information to answer the rest of these questions. Number 8 asks, what's the slope of your graph? Now, if you remember, slope is the m of y equals mx plus b. So the slope of my graph is 535. Because this is physical science, we apply the math, so it actually has to have units. And the units for the slope are psi per day. Now, how do we get that? Well, slope, remember, is rise over run, right? And because you're taking how much the y changes divided by how much the x changes, you just use those units. It's the psi divided by days. So it's psi per day because there's an actual application to this. And you need the units. That is a point. Okay, so make sure you do that. Now, number 9 is saying, well, what does it mean in the context of this experiment? Like, what does it mean in reality, right? So what we're trying to say here is that the slope is how much the braking pressure increases every day. So we can say it means that the braking pressure increases by 535 psi every day. Okay? All right. So that's the slope part of this. Let's go to the y-intercept. If you recall b in y equals mx plus b, that's the y-intercept, right? And the y-intercept is just where that line crosses the y-axis. That's all, right? And so what is the y-intercept of this graph? Well, if it's mx plus b, it's negative 1,534. And there's units to that, right? Because it's a y value, it's going to use the y units, which is psi. Okay? So that's the actual y-intercept. Now, what does the y-intercept tell you about the graph? Well, in any graph, the y-intercept is the starting point, right? It's whatever the y is at whatever 0x. So at 0 days, it's the braking pressure. So it is the braking pressure at pour, whenever you poured it, right? The very first day. Now, to be fair, that doesn't really make a lot of sense for 2 reasons. Number 1, you can't really have a negative pressure on this thing if you're pushing down on it. That's just not a thing. Also, you can't really break the concrete or the mortar right after it's poured because it's still goopy and everything, right? So it doesn't make sense, but it will actually tell us a little bit about the math if you've got even better data than what I have. Okay? Now I'm going to skip number 12 and 13. I'd like you to think about that. Just notice this says 2 ways. And lastly, right here, it says, what do you predict the braking pressure to be at 60 days? Well, the nice thing is that, remember, 60 days, that it would be an x value because days is on the x-axis. So all we have to do is take our equation, right? Y equals 535x minus 1,534. And all we're doing, when we ask this question, what is the braking pressure, which is y, at an x of 60 days? So all we really do is just say, okay, y, don't know what it is, but I know the rate of change, the slope is 535, and we're going after 60 days, so we just plug in 60 for x. And then we subtract 1534. All right, so let me open up my calculator here, and let's do this. So let's do 535 times 60, and I get that, and then I have to subtract 1534, and I get an answer of 30,566 psi. Okay? Now there's one other cool way to do this, and that is if you take your chart like I did here and actually extend the days to 60 and extend this a little bit higher, all you got to do is actually just look to see at day 60 what is the y value up here. And as you can see, it's a little bit above that line, which is 30,000. Does that comport with what we just did? Yes, it does. 30,000 and a little bit, 30,000 and a little bit. So it looks like everything is good to go. So if you are analyzing this data, this is how you do that. And you can use this for other types of questions as well. As always, if you have any questions, just let me know, and I will see you in